Hi everyone, I am Navyashri, pursuing second year engineering at Sri Venkateshwara College of Engineering, USN 1B23CS112. Today I am here to discuss the topic which comes under the course Discrete Mathematical Structure, course code BCS 405A. Today's topic is pigeonhole principle. Let us discuss about the introduction. The pigeonhole principle is a fundamental concept in discrete mathematics, particularly in combinatorics. It asserts that if more objects, pigeons, are distributed into fewer containers, pigeonholes, then at least one container must hold more than one object. Despite its simplicity, this principle has profound implications across various mathematical and computational fields. Next, basic formulation. The basic form of the pigeonhole principle states, if n plus 1 or more objects are placed into n containers, then at least one container must contain more than one object. This principle is initiative if you have more than one item in a container, duplication is inevitable. Next, generalized pigeonhole principle. The generalized version extends this idea, kind of technical. If n objects are placed into k containers, then at least one container holds n objects. Here x denotes the smallest integer greater than or equal to x. The generalized version extends this idea, kind of technical. If n objects are placed into k containers, then at least one container holds n by k object. Here x denotes the smallest integer greater than or equal to x. Next, illustrative examples. Birthday paradox. In a group of 367 people, at least two individuals must share the same birthday. Since there are only 366 possible birthdays, including February 29. Sock drawer problem. If a drawer contains 10 red or 10 blue socks, randomly selecting 3 socks ensures at least one matching pair, as there are only 2 colors. Since there are only 366 possible ways. Exam scores. In a class of 1 or 2 students with scores ranging from 0 to 100, at least 2 students must have identical scores, given only 101 possible distinct scores. Ensures at least one matching pair. Next, application across fields. Computer science. In hashing algorithms, the pigeonhole principle implies that if more items are hashed, then there are buckets collisions. Multiple items hashing to the same bucket are unavoidable. Next, in number theory, the principles help prove that in a set of n plus 1 integers, there exists at least one pair whose difference is divisible by n. Graph theory. It is used to demonstrate that in any group of people, there are at least two individuals with the same number of acquaintances, assuming mutual relationships. Implies that if more items are hashed, then there are buckets collision or unavoidable. There exists at least one pair whose difference is divisible by n. Next, strong form. The strong form of the pigeonhole principle states that if q1 plus q2 so on up to qn minus n plus 1 q1 q2 so on up to qn minus 1 objects are distributed into n boxes, then at least one box contains one object. Here you can see the formula. This form is particularly useful when dealing with distributions where each container has a different capacity or threshold. This is the statement of strong form. Next, conclusion. The pigeonhole principle, while straightforward, is a powerful tool in discrete mathematics. It provides a fundamental approach to providing the existence of certain conditions or outcomes without explicit construction. Its applications span various domains including computer science, number theory, graph theory, making it an indispensable concept for problem solving and theoretical proofs. It also provides a fundamental approach to the existence of a certain conditions or outcomes without any explicitures. Thank you.